acids, whether they're in the favorable condition, the regions or the non-favorable regions. Now, it all starts from the selection of disease. If I want to do a research, the first thing is I have to decide what disease I have to work on. So disease selection is the most important aspect. And how we select the disease? Based on the pathways. So for any disease, there is one of the pathway which has been altered. The physiology has been changed into pathophysiology. We have to identify that. What all enzymes are involved in this pathophysiological process, that has to be understood. And when I say enzymes, what are enzymes made up of? They are nothing but proteins. So what we are selecting here, we have to select the disease. Based on that, we have to select the enzymes which we have to pick as a target enzyme. Either we can inhibit the enzyme, we can promote the enzyme, right? Now, building the receptor. So as I said, as many of you agree, and you all already answered, that PDB database is one of the most important database wherein we can find the 3D structure of the protein. Next, the availability of the structure should be processed. Images of the structure before it has to be selected for the study. Identification of the active site. Theoretically or hypothetically, we have to identify the active site. If I say the active site for HMG-CoA enzyme reductase enzyme inhibitors, right? There should be some active site wherein you must have all come across alpha site, beta site, all those things, alpha receptor or whatever. There will be different sites for each and every protein. So which site exactly this drug is going to bind and produce its action? For example, atorvastatin binds to XYZ pose of the protein. So similarly, rosuvastatin also has its own activity. It is also active on the same enzyme, but maybe the pose is different, or the angle is different, or the binding site is different. So that is how the identification of active site is very important. The active site within the receptor should be identified first. The receptor may have many active sites, but one of the interest should be selected based on the literature or based on the previous research, right? So all of we do research, right? We are not going to search a novel thing. We are just going based on the literature survey. We are going to conduct a research. So we are just going to select a active site based on the literature. Now, biochemical pathways could become abnormal, and it can lead into results. As we all know, biochemical pathways are the initial precursors for the induction of the disease. So select a target which is responsible for disruption of the biochemical process, right? So what are the categories of targets? The targets can be either enzymes, receptors, or nucleic acids, right? Majority of diseases we use enzymes or receptors. If I want to check, if I want to compare an XYZ drug with a paracetamol, then it should have a similar sort of shape. It should bind to a similar site so that it can produce a similar activity. That is how we can define and measure. Research is conducted on receptors. But nowadays, we are more into nucleic acids. We want the end result. We want the more specific targeted drugs. So nucleic acids are also can be used as the targets or the receptor. Now, ligand selection and preparation. So ligands are available, as someone said. So ligands are present in PubChem is the major website where we can find the 3D structure and 2D structure of the ligand or a chemical. And next is zinc database. Or if there is no database, if your drug, if your ligand is not present, it is not established, it is completely novel, there is no structure available. In that case, we can use some tools, certain tools to draw the structure of the compound, your molecule, by using certain softwares like ChemSketch or ChemDraw, right? Similar docking, ligand is docked with the receptor interaction is there. The best fit ligand is selected. So that ligand has to be selected based on the best fit. So where we can find what is the application of computer-aided drug design? So it is one of the major components which will fall between target discovery to up to preclinical trial. It is going to support us. Before the preclinical trial kicks in, this is CAD will be always as a supporter for the process of drug discovery. And these are the different techniques: ligand-based CAD, structure-based CAD, and system-based CAD. I was explaining about network pharmacology, molecular docking, molecular simulation. Here we can find the answer. Structure-based. What is structure-based? Molecular modeling, protein structure prediction, molecular docking can be done, and followed by molecular dynamics. Whereas system-based, there is network pharmacology. Network pharmacology is a tool which is also very essential when you are using herbal plant, when you are using phytochemicals. If I'm selecting a herbal plant, there are more than 200 phytochemicals. I need to shortlist them. I need to select the my area or my phytochemical which is of interest, so that we can conduct the study. What are the softwares used? So these are one of the most simplest of softwares which can be used by anybody, which doesn't require any coding. It is very easy to use. Provided there are some complex. Schrodinger is paid one, and these are all softwares which are used. Autodesk Vina is one of the most classical and most widely used software which can be used for docking and simulation. Not for simulation, only for docking. For simulation, we have to use something called as MGL tools, and that is GROMAX. It is called as GROMAX, which is used, and we require a special computer for that. Next is Pyrex, which is most user friendly. Many of our students have used this. Pyrex is most user friendly. Anybody can use it. Just you have to log in and you have to start using that Pyrex. Hex and MallSoft. MallSoft is also very user-friendly interface which can be used as a tool for the process of docking. Next is visualization. So once we dock, right, we cannot use the same compound, we cannot use it in the publication because it is not that clear. So in the visualization software, we depend on a specific software which is called as Discovery Studio. I know many of us must have heard of this Discovery Studio. There is one more called as PyMol and RASMol. So even PyMol can be used. It is also very user-friendly, very simple. It will save a lot of time. Within one day, we can have this data ready. What are the steps involved in the molecular docking process? The first step which is involved is extraction of the receptor or the protein. If it is available in the database, well and good. If not, then we have to create homology modeling. And if you are creating homology modeling, that has more weightage because it is novel. It is not yet studied. You are studying it for the first time. That is how homology modeling carries its own weightage. If you have homology model structure, your publication has its own weightage. So if it is available in PDF data bank, or molecular modeling or homology modeling can be conducted on the protein. Coming to the extraction of ligand from the PubChem database. So the 3D structure of the ligand has to be downloaded from the PubChem database. Followed by prediction of the drug's biological activity, which can be done. As I was telling, that Lipinski rule, right? Many times it's not possible for us to run that Lipinski rule, or we are not that well versed with Lipinski rule. So in that case, there's a website which is called as Pass Online. Has anybody used this Pass Online before? Use that? Swiss Admit you are used. Okay. Pass Online is also the same, which is going to just use prediction that this can be used as a specific result. So I'll be explaining that Pass Online also. So protein structure validation can be done. So as I said, Ramsden plot, which can be done by using this software called, it is a database called as Project, and which is having saves, which is version 6, which can give us idea about the nature of the protein, how the nature of the protein or protein structure is having its residual amino acids in the favorable region or non-favorable region. Next is preparation of molecules for the docking process, and docking of the receptor and ligand, and screening of the results. So all these techniques are generally followed. No matter what software you are using, all these techniques remain constant, almost, right? Now steps to be followed in molecular docking. So extraction of the receptor is the most important step. From the PDB file, I'll be I would not have a hands-on training. I'm just having screenshots of whatever example I'm just going to give here. So I took an example of 3D-dimensional structure of protein from the 3D database, which is having a code of 7K2F. This is the protein code which will be having our protein of interest for the research. 3D structure of a receptor obtained from PDB, it is bound with ligand molecule, then the bound ligand molecule should be removed using PyMol software. So as I said, energy minimization has to be done. So whatever, if your protein is already docked with the ligand, it is already available as a structure in the complex with the ligand. In that case, we have to have an energy minimization step has to be carried out, and we have to prepare the protein for that. So this is how the PDB data file or PDB looks like, where you have to search about your protein, and it is going to give us the structure of the protein, and we have to download the structure in the document, in the PDB document. Now, next is extraction of the ligand. So the ligand structure should be obtained from the PubChem website. So PubChem website is free. You have to just go and type about your drug of interest or a ligand of interest, and it is going to give us the structure, and we have to download it in the form of STF format. So I'll explain that. So the ligand structure should be obtained from the PubChem website. The chemical structure should be saved in the STF format. This STF format should be converted into PDB file using FileMod software. The process file is converted into further into PDB-QT format, which is required. So whatever the ligand is downloaded, it has to be converted into PDB-QT format before docking. So these are the steps involved. Without this, the docking cannot be performed. Using Pyrex software, which is open source software, and there is one more software called as OpenBabel. OpenBabel is also integrated in Pyrex software. If not, OpenBabel can be downloaded. It is also freeware. We can download and we can use this for conversion of STF file into PDB-QT file. So this is how the extraction of the ligand. I have planned to just lively demonstrate how we can download a structure, any structure, any chemical of your knowledge which can be searched here. If someone interacts, or else I already have a open page here, so I'm just going to internet is not there. This one, just a second. Right? So I just copied this and explain why I copied this. Before that, I just explain coming back to the slide. So this is how the structure looks like.